Now, it's very common for reaction kinetics, right, to give you questions that ask you to interpret different graphs, okay, for the different rate of reactions, or in some cases, they ask you to draw a whole new graph depending on the factors that they provide. And you have to draw a graph accurately that depict the correct rate of reaction. So, for example, we look at this case over here. When you are measuring the volume of the product, which is a gas, right, there are three different graphs that you can plot over here, right? Let's say you have this 1 mole per dm cube at 25 degrees Celsius, right? And then you have 1 mole per dm cube at 60 degrees Celsius, and you have this 0.5 mole per dm cube at 25 degrees Celsius. So how do I interpret these kind of graphs? So if you look below, right, there's two things you need to take note when you're interpreting graphs for reaction kinetics. The first is the gradient. The gradient represents the rate of reaction. So if you are changing factors that could affect the rate of reaction, you need to pay attention to the gradient. Next is the plateau point. Always ask yourself, what is the maximum amount of product that can be produced? Okay? Now, if a factor changes this maximum amount of product, you need to pay attention to the plateau point. Usually, a change in concentration or volume or mass of your reactants, right, will affect this maximum amount of product that can be produced. To calculate this specifically, you need to use your mole concept. So if you haven't checked out the mole concept video, I recommend you go and check out that lecture. It's very important when it comes to chemical calculation.